Ready? Let's look at the next section here, 2.7. It's piecewise functions. So it's not too bad once you get the hang of it. It's easier if you understand graphing. But what you really need to focus on or understand is the notation we talked about last time. Remember, we said h of -4 means you plug in -4. H of -1 means you plug in -1, right? It's just that now h is a little more weird looking. And h is still a function, but is made up of multiple pieces. That's why it's called piecewise. So the function is defined by, in this case, three different functions in three different spots. So depending where we are at, the function will change shape. So if we're below -2, it looks like this. If we are between -2 and 2, it looks like a parabola. If we're at 2 or above, it becomes a constant function, 1. So you have to remember, you need to be good at the parent functions or have them at the ready. Okay, so now -4 is below -2, right? So this guy right here would go into this function. And then you just do the math. Plug in -4, and then you see what you get, right? -1 is between here, so you would plug that guy in to this one. So it'd be -1 minus 1 squared. And then you get your answer, whatever it is. Who cares what the answer is? Right now, all that matters is do you understand what we're doing? If we're at 2, equal to 2 or above, then it's equal to 1. So I can't really plug it in here. It's always 1 no matter what. So technically, when you plug it in, you get 1. That's all. So that's what you would do when they ask you to find the values, right? Find the outputs of these. Just remember which one is it going to go into. Okay. Now these form this interval increasing and decreasing and constant stuff, it looks harder than it is. All you have to remember, right, just picture from left to right. It's always going to be left to right. Picture a little car just kind of driving going up the hill. So if I'm going left to right and I'm going up, then I am increasing. This is always going to be true. Going downhill from left to right, then I'm decreasing. There it is. If I'm just going straight, not going up or down, then the function is considered to be constant in that section. And by section, we mean the interval I, right? This I, whatever. So that's what this is saying in maths terms and symbols. What I just said using the car analogy, just make it as simple as possible. Left to right, increasing, decreasing, whatever. So these next few questions are going to be talking about that idea. So check it out. A to B, I'm going down, left to right. So decreasing. B to C, I'm going up, increasing. C to D, I am constant, right? Constant. D to E, I'm going up again, increasing. That's pretty much it. So if you remember that idea, then you can see when it increases and when it doesn't. Then you'll just write it in math terms, right? You would say, oh, well, um, A to B is going from -5 to -1. That's where I am decreasing. I'd be okay. And then so that you could say all the sections where it's increasing, all the sections where it's decreasing, and create multiple parts. Like they didn't ask, but if they said, where is it increasing, you would say, well, from -1 to 1, I'm increasing. And then again, from 3, let's do union. From 3 to 5, no, 6. That's it. Still not too bad, right? Here, decreasing, constant, increasing, constant, increasing. So this is when we do the whole uh, actually label the section. So I'm increasing from here to here and here to here. So put that in math symbols or intervals. It'd be 0 to 1 union 4 to 6. And then decreasing, right? Oops, that's horrible. From -6 to -4. And then, actually, that's the only place I'm decreasing. So that's it. Constant from here and here. So that would be what? -4 to -1. 1 to 4. Anyway, hope that makes sense. Left to right, if I'm going down, decreasing. If I'm going up, increasing. If it's constant, straight ahead, or constant. Anyway, so that's a few examples on increasing and decreasing. Just this is some notes just to remind you, and don't forget the card thing. Card thing helps, I think, but it's up to you. Here they want us to actually graph it, and where they go back to piecewise functions. Uh, so remember that this is a constant function, right? Well, I shouldn't say the whole thing, but this right here, right? That's basically saying y equals 3 when we're below -2. And then here it's saying, well, that's a different function. It's y equals x when we're between -2 and 2. And then we go back to this one again. Okay, so remember what a constant function looks like. Y equal to 3 when it's below -2. So 3 is right here. -2 is right there. So we'd say, again, it's not equal to, so you would have a hole here, and you'd have a constant function going that way. Now, if it's above 2, we're back to 3, so I'm gonna go and do that part first. Hole above 2, we're gonna get the constant function 3. So now we just do this one. It's the identity function from your parent functions of x equal to x between -2 and 2. So it's gonna be defined here. You plug in 2, you get 2 back. Plug in -2, you get -2 back. So like this. Anyway, um, it becomes a lot easier to do this if you remember what the functions look like. Like, what does this look like? What does this mean? But all it's telling you is graph this function at this location, graph this one at this location, graph this here. That's it. All All right, let me put the graph for just one more time. Just I don't know if this will help or not, but right. You could graph each one separately and say, well, I got y equals 3. There's my constant. I got y equals x, which is this. Then I got the 3 again. So basically, we cut it off. Let me zoom in a bit. There's -2. Excuse me. Yeah. So we have a hole here, we said, and a hole there. And then we're gonna disregard everything below this and everything above this. So ignore that. Pretend it's not even there. So you have this graph here and this graph here after 2 and below -2. So this one right here is f equals to 3 when x is greater than 2. So here's 2, I'm above 2, so that's what's going on. And then this one is still, again, they give us the same function twice, which doesn't usually happen, but there's nothing says they can't. So now again, it's f equals to 3 when x is below 2. So there's -2. Oops. So there's 2. So it goes that way. Then in between, it says that this little purple section that's not crossed out, f will equal x between -2 and 2. These sections there. And it's equal to, so these have solid endpoints there. All this is gone. Anyway, but that's what we did on the other paper. I don't know if it helps seeing the pretty drawings on Desmos or not, but we're basically taking three functions and just kind of cutting them off, putting them in sections, and then connecting them together. Sometimes they don't connect exactly, they might jump, but it won't violate the definition of a function. Okay, so back to the graph or PDF. So on this one, you'll graph it again and just see, okay, is it a function or not? Or is it continuous? So 5 and 6. Let's look at the key before I get too deep in there. Hmm. Yeah, check it out. It's better for you to see the answer. You see how it jumps? It's still a function, but because of that jump, we say it's not continuous. So for now, because we can't use calculus, if you take your pencil off the paper when you're graphing, and you have to jump down here, then it's not continuous. Here we could just connect everything, no jumps, no gaps, so continuous. Okay, so that's what you tell you. You graph those, and then look at the graph. So see what's going on. So graph this the way I showed you, right? Graph this line below negative or below or equal to 2. Graph this one when you're above 2. So you're gonna have those two lines, which looks like this. Here, two lines. And then this guy will have three different functions, constant, parabola, and a line. Graph them in their specific locations, and you get this guy here, and you'll see it's not continuous. So you have to graph it in order to determine if it's continuous. 7 and 8 we're gonna have to do on paper. It's just we'll do 7. I'll leave 8 to you. Okay. You write the question down. I'm going to shorten the question. This is number 7. Find the difference quotient. It's just a lot of algebra, so I'm going to try to make it as simple as possible. Do it in steps of f of x. So f is equal to this parabola. Difference quotient is this guy. So f of x plus h minus f of x over h. And h cannot be 0. Yeah, it looks ugly. I don't like it. Okay, so what I recommend is find this one first. So remember that means f of whatever means you're going to plug it in. So I'm plugging it in. Everywhere we have an x, you're plugging in an x plus h. So that becomes 5 times x squared plus 2xh plus h squared minus 3x minus 3h minus 1. So FOIL this out, use the square method or box method or multiply twice, or use a formula like I did. You can end up with this. Distribute the 3, negative 3 on both gives me this. These two terms. Negative 1's still there. 5 is waiting to be distributed in here now. So that'll be 5x squared plus 10xh plus 5h squared minus 3x minus 3h minus 1. Okay, so now we got that first part, so now let's do that piece we just did and subtract the original function f, right? So that means take the result we just got and subtract the original. So things are going to cancel. You can see right away. Distribute your negative and cancel the terms. There we go. So once you distribute that negative, things are going to cancel, leaving you with these two terms. Now, final step. You could do this all at once if you want to, but I think it's a little easier to follow if you do piece by piece. So now the final thing, which is what they're really asking for, is divide by h, take the result, and divide by h. And you can see there's a common h up top, so factor it out. And you'll see that they cancel. So the difference quotient is this. So it's always going to be the same thing no matter what f is. It's just the difficulty will change and the steps will change depending on the function. So if you have a square root function, then it'll be different. You have a rational type or a line or a cubic, it'll be a little messier or easier. It just depends. So it'll just come down to your algebra skills and the function. So we did a parabola type, right? And we plugged in x plus h. And you can see it got a little messy, but it wasn't too bad. Subtract the f, cancel a bunch of terms, and then we divide by the h. We took this result divided by h, which got us to here. But yeah, I'd say practice that a few times so you can, and I highly recommend doing it in pieces. And you'll start to see it's not too bad. Anyway, that's it for 2 point, whatever this is, 7, 2.7.